All right, welcome, budgets and optimal consumption. Final video of this unit, what you will learn, how a consumer determines her optimal combination of goods to consume. All right, so the first thing that we need to keep in mind is that we have only a certain amount of money, and that's going to be called the budget constraint. That's going to be the first thing we need to know before we can figure out our optimal consumption bundle. Budget constraint limits the cost of a consumer's consumption bundle to no more than the consumer's income. So we're going to take it as the person's income, that's all the money that they can spend. So that will be our budget constraint. So this person made $675.80, which means that they are allowed to consume up to $675.80, but no more. So that's going to represent a constraint, a limit on the amount that they can spend. And we just see a graphical representation of that in here. This is a budget line. So that blue line, downward sloping, represents the budget line, shows all the consumption bundles available to a consumer who spends all of their income. Now again, we are going to make this simplifying assumption that you will be very glad for, that there are only two goods that this person can use their income on. In this case, this young lady, she can either buy swimsuits or flip-flops. And they give you all the information here, but you could figure it out on your own. She has an income of $80. If she spends all of her money, all of her income on swimsuits, that means that she would be able to buy 4 swimsuits. If she spends all of her money on, all of her income on flip-flops, 80 divided by 10, 8. Or she can do some combination of the two. She could buy 3 swimsuits, so that would be 3 times 20 is 60, plus 2 times 10 is 20, 60 plus 20 is 80, or etc. This should look very, very much like a PPC, because it's the same thing, except this time instead of talking about what can be produced, we're talking about combinations of what can be consumed. So I don't think we need to spend any more time with that. Budget line, very simple, just like a PPC, except we're looking at it for consumers now. So how do we determine the optimal consumption bundle? So how do we figure out whether she should buy only swimsuits or only flip-flops, or what combination of swimsuits and flip-flops is correct for her? So this is where optimal consumption comes into play. First of all, to define it, it's the consumption bundle that maximizes the consumer's total utility given her budget constraint. So we're not going to say that her optimal bundle is 10 swimsuits, because she can't afford 10 swimsuits. So it has to be within that budget line. It has to be somewhere on that budget line, because she can't go past that. The idea here is to maximize total utility, and so we're going to find that at the peak of the total utility curve. And so what this does here, this chart, and really I think the next chart's going to do a little bit better of what we need to do. But the idea here, it says Sammy's, so this is a different scenario. Sammy's total utility is maximized at bundle C, where he consumes 2 pounds of clams and 6 pounds of potatoes. And the reason for that is looking at the lower one, that's the total utility, right? If we start at point A is a different combination of clams and potatoes. In fact, it's 0 clams and 10 potatoes. That gives him a utility score of somewhere about maybe 56, 58-ish. B, it goes up. C, it goes up even further when he has 2 clams and 6 potatoes. At D, it's now falling. When he has a little bit more clams and fewer potatoes, it starts diminishing. So what we see is when we move up from point C on the lower one, move up to point C here, which, look at me, great straight lines I'm drawing here. That's showing us that is his optimal consumption bundle. It matches, it's along his budget line. All right, the way that we're typically going to do this, though, is we're going to look at marginal utility per dollar. So, again, marginal utility, we're looking at the additional utility gained from spending $1 more on that good or service. So in this case, we have soda. All right, so this is just one single good. Soda costs $2.50. And we see what happens to the person's marginal utility. The first soda is a score of 40, the second down to 35, the third down to 30, and so on. So we see our principle, right, of diminishing marginal utility. Total utility is increasing, but over here, the green column, that's the one we care about here, marginal utility per dollar. So the way that we're going to calculate that is very simple. It's going to be the marginal utility divided by the price. So 40 divided by $2.50, which equals 16. So 16 is this person's marginal utility for one soda. Now what's going to happen? The second soda, the marginal utility falls to only 35. So now it's 35 divided by $2.50, which equals 14. And again, as you notice, the marginal utility per dollar is now falling. All right, so that's what we do with marginal utility per dollar. It's how you solve it and figure it out. Now the last thing to do is to see what we do once we have figured out our marginal utility per dollar. The optimal consumption rule states that the marginal utility per dollar spent on each good, because remember we're talking about two goods now in our bundle, marginal utility per dollar spent on each good in the consumption bundle is the same. So our MU, marginal utility divided by P, has to be the same. If it's not, what that's going to tell us is that we need to buy more of one good and less of the other. We do that until our marginal utility per dollar is equal. So again, you have how to figure that out. If there are two goods, good X and Y, the marginal utility of good X divided by the price of good X equals the marginal utility of good Y divided by the price of good Y. Or like I said, MU divided by P has to be equal for both. Now this chart is assuming a $10 budget constraint. All right, we have two goods. We have apples and we have oranges. An apple costs $1. Just highlight that for you in case you're not seeing it. An orange costs $2. All right, now we look and we see, all right, the first apple that this person buys, the marginal utility per dollar, because that's what we're looking at, is 10. Okay, that costs $1, marginal utility of 10. Then we look over here, the first orange that person buys, marginal utility per dollar is 12. Well, what we need to do here is we need to find, again, because remember our marginal utility per dollar has to be the same, and our total amount spent has to be $10. It cannot be more, and we don't want it to be less, because if it's less, then we could always, by buying one more of either good, add to our marginal utility. So when are these equal, and when does it add up to $10? So the answer is highlighted for you already, unfortunately. It's this number 8 here, which represents 2 apples. And then we have the number 8 over here, representing 4 oranges. So let's see if this qualifies. So our first thing is, all right, 2 apples cost $2, because $1 times 2 is 2. 4 oranges, 4 times 2 is 8, so 2 plus 8 is $10, so it is matching our budget constraint. And the second and most important thing is that our marginal utility per dollar is the same. It is 8 for both. So this person could not be better off by getting more apples or more oranges and substituting out the other. This is where they're perfect. Because again, think about it. If we had gone to a third apple, marginal utility is only 7. But now we could only afford 3 oranges. Marginal utility is 9. What that's telling us is that we are still getting more utility out of oranges than we were out of apples. So we'd be better off getting one fewer apples and having more oranges. So again, we go until they're equal. This has been a LaMoney production.
God bless you if it's good to you. America, please take